This is lesson 6 covering all of the other things in the solar system, and the first thing we want to look at is an asteroid. So, here's a crater on an asteroid. Right? This is Vesa. It's the second largest asteroid in the asteroid belt, but look at this thing. Keep your eye on Claudia, the crater Claudia. What I'm trying to get at here is what? Asteroids can be really, really, really big. Claudia here was pretty big. I'm guessing Claudia is about the size of Pine Island. But on the asteroid itself, it's quite small. Okay. Other asteroids we see, or other craters we see, this is the Snowman asteroid. We see some scrapes in this asteroid. Here's the mountain on the bottom of the asteroid. This mountain is about 4 times taller than Mount Everest. Here's what it looks like. So a 3D view of Vesta. Right? Is it a sphere or not?
Almost.
It's close to a sphere. Well, yes, an asteroid is a rocky object that is smaller than a planet that is orbiting the star. They can be very big, like the one we just saw, or they can be smaller. The one we just saw, if we parked one end of it in Pine Island, the top side would reach all the way to Chicago or into North Dakota, depending on which way it tipped over. The one we just saw was very big. So that's an asteroid. Now asteroids, as we studied them, we learned, hey look, they seem to all be in one place. So we named this area the asteroid belt. So here's a picture of all the asteroids we have mapped, all the large ones anyway. What you'll see is that outside the orbit of Mars and inside the orbit of Jupiter, we end up having this big white band of asteroids. And this is the asteroid belt. So this asteroid belt ends up being the region between Mars and Jupiter where most asteroids orbit the sun. And unfortunately, the asteroid belts are not what you think of when you think of asteroid belts. Here's what I think of when somebody says asteroid belt. They're going into an asteroid field. Now if you look, right now it looks like all the asteroids are kind of going the same direction. But in a moment here, now the asteroids are all going different directions. There's one going towards and one going away, and some crisscrossing across the screen. So I'd hate to burst everyone's bubble, but asteroids end up just sort of orbiting like planets. They're pretty spread out, even though they look like they're really dense in this picture. You have to remember, solar system's really, really, really big, and so there's a lot of space between these. We sent a lot of probes out through the asteroid field, and they just haven't hit anything. So it's mostly empty space, unfortunately, unlike that video. Up next, a meteor. So when you see a meteor, this is what you're seeing. A meteor is also known as a shooting star, but it's just a brief streak of light that's seen when an asteroid enters Earth's atmosphere and it burns up. It's also known as a shooting star, but it's not a star at all. A star is this huge ball of gas, whereas this just looks like a star that's shooting across the sky. It's inside of our atmosphere. So shooting star is not the right thing to call it, but that's what we call it anyway. However, sometimes meteors can make it to the ground. So here's a meteor coming into our atmosphere. It breaks up, gets very, very bright, and then some little chunks make it all the way to the ground. Right? The boom was so loud that it broke many, many windows as this happened. Here it is again. They said if this did not break up, it would have caused a lot more damage. If it would have hit the ground whole, like many people would have died. And because it broke up, it was like a nuclear bomb going off, and it broke a ton of windows, but people just got cuts and nobody had to die. And so that was pretty good. And so a meteorite is an asteroid that hits the surface of a planet or a moon after traveling through space.
I didn't even get the rest of it.
Okay, last one is a comet. Here is a picture of a normal, typical comet, what we will see from Earth. What we'll see is a nucleus. So this is kind of like an asteroid, a big hunk of rock and ice and whatever else. But as it gets closer to the sun starts boiling and steaming and breaking off little bits, and you see this dust tail start forming behind it. So a comet looks like this big thing here, but what a comet actually looks like is something more like this. This is Comet 67P. This is a comet that we sent a spacecraft to orbit around, and then we tried to send a lander to land on top of it. And the lander didn't do perfectly, but we did get some really good science about these comets, which are basically part of the building blocks of the solar system. So Comet 67P here is got a lot of interesting stuff going on. It has its own gravity, you know, so all of this loose stuff here is hanging on to it. And, you know, we can see that it's really, really big. Here's the comet next to a city. So not a small thing. You know, this is big enough to have something orbit around it and a lander land on it. Well, a comet is just a ball of ice, rock, frozen gases, and dust that orbits the sun. It orbits the sun in a really, really wide elliptical orbit. Looks like this. The comet has this wide orbit. It'll go fast around the sun, and then it's slowing down, slowing down, slowing down, and it pretty much stops, goes slow, and starts falling towards the sun again. Wings around again. A comet might take 100 years to do one loop like this, but this bottom part would only take days, weeks, or months, depending on how close to the sun it gets. Okay. Now the comet we're seeing here is either moving away from the sun right about here, so it's got a lot of dust and this tail, or it's falling towards the sun. And so what we'll see in the sky is something like this, and every night it'll sort of move where it is across the sky. So the next night, maybe this would look like this in the sky, and the next night it would look like this. It's not moving like it looks like it's flying through the sky. It's usually moving something more like that.